Hello and welcome to Math 95 Online. This video is lesson 6.5 from the Math 95 book for Columbia Gorge Community College, and it's about complex fractions. Now, complex fractions. You might be thinking, hey, this is probably going to be hard because it's called complex. This is not true, actually. We've done some of these before, we just didn't know it. For example, a over 4b over a over 6b squared. This is called a complex fraction because it's a fraction over a fraction. So there's just a lot going on here, but we've actually done this problem before, right? We just saw it a little bit differently. This is the same thing as a over 4b divided by a over 6b squared. This divided by symbol and this divided by symbol mean the same thing. So we did this in section 6.3, I believe, or 6.2, 6.2, where we flipped and multiplied. So we're doing that exact same thing here. It just looks a little bit different. So the way that we would solve this problem is flip either the bottom, or if you have it written like this, the right-hand side, and multiply. And when you do this, we can cancel out common terms on the top and the bottom. So a divided by a is 1. 2 goes into 4 twice, and 2 goes into 6 3 times. And the b on the bottom cancels out one of the b's on the top. So we are left with 3b divided by 2. So this is complex fractions. Let's look at another example. This next example, I'm going to show you a couple ways to solve the problem. Okay, the example and method 1. The example is 1 plus 1 over x divided by 1 minus 1 over x. Now we can't do what we did in the last problem of just flipping and multiplying because we don't have just one fraction on the top and one fraction on the bottom. So what we can do is we can simplify the top and simplify the bottom and then flip and multiply. So for the top, we want to get a common denominator. The LCD for the top is x. So what we will do is we will multiply by x over x here. And the LCD for the bottom is also x. So we will multiply the top and the bottom of there by x. And then the result will be x over x plus 1 over x over x minus 1 over x. This gives us x plus 1 over x minus 1 over x. And now you can see that we have a fraction over a fraction, so we can flip the bottom and multiply. So x plus 1 over x times x over x minus 1. These x's cancel out, and we are left with x plus 1 over x minus 1. And that's our solution. So that is method 1. Method 2, for this type of problem, is a lot shorter. And so let's get our problem up here again. 1 plus 1 over x over 1 minus 1 over x. And what we want to do here is we want to multiply the top and bottom by the overall LCD. So the lowest common denominator out of the whole thing. In the last method we did the lowest common denominator of the top and the lowest common denominator of the bottom and got the common denominator and added or subtracted. But here we're going to multiply the big fraction by the lowest common denominator, which is x. So we're going to multiply by x over x. Then what we see is we're going to distribute the x there and distribute it down here. So 1 times x is x. 1 over x times x is 1, because the x's cancel out. Divided by x times 1, which is x, minus 1 over x times x is 1. So that gives us the answer straight away, which you can see is much simpler than what we did in method 1. After seeing both of these methods, you might think, well, I'm always going to use method 2 because it was the quickest, but that's not always the case. It is the quickest if the top and the bottom have a very similar lowest common denominator. But if they're vastly different, then it actually is much more work, which we'll see in a later example. So let's do another example. This time we're going to have 1 over z plus 1 minus 1 over z minus 1 all over 2 over z plus 2 minus 2 over z minus 2. Now, if we look and decide which method we want to use, method 1 or method 2, in this case, all the denominators are different. They have nothing in common. And so, or no factors in common, I should say. So this leads us to think method number 2 is not going to work very well because we're going to only get one thing to cancel out and we'll be left with 3 different factors. So it's not a good idea to choose method 2. So let's simplify the top and then simplify the bottom, then flip and multiply. So on the top, the LCD is z plus 1 times z minus 1. And the bottom, the LCD, is z plus 2, z minus 2. So we multiply by what's missing in each factor. So here we have z plus 1, so we're missing the z minus 1. So we multiply by z minus 1 over z minus 1. And here by z plus 1. In the bottom, here we're missing z minus 2, so we multiply by z minus 2. I shouldn't have used z's and 2's, that's a little messy, but we'll be okay. Z plus 2, z plus 2. Alright. So, if we just take this one piece at a time, the thing that tends to happen when students make mistakes on these or just get discouraged is if you look at the screen right now, there seems to be a lot going on, and so maybe that gets confusing. So the best advice that I have on these is just to go step by step, one thing at a time, and just keep cruising along and take deep breaths often. Alright, so here we go. We're going to do z minus 1 times 1, which is z minus 1, minus z plus 1. Here the parentheses are important because this minus sign has to distribute, right? Divided by z minus 1 times z plus 1 all over. Now on the bottom, we have 2 times z minus 2, which gives us 2z minus 4, minus 2z plus 4 divided by z plus 2, z minus 2. It doesn't matter the order if you say z minus 2, z plus 2, or z plus 2, z minus 2. It's multiplication, so the order does not matter. Okay. Now here we have z minus z, which is 0, and negative 1 minus 1, which gives us negative 2 over z plus 1, z minus 1, over 2z minus 2z is 0. Negative 4 minus 4 is negative 8 over z plus 2, z minus 2. Okay, need to scroll down a little bit so we have some more room. Now we get to flip and multiply. So we have negative 2 over z plus 1, z minus 1 times, this is going to now be on the top because we're flipping it, z plus 2, z minus 2 over negative 8. So let's see, none of these guys cancel out, so 2 goes into 2 once, 2 goes into 8 4 times, and the negative divided by negative means we're going to have positive. So we get z plus 2, z minus 2, whoops, over z plus 1, z minus 1, and we'll probably put that 4 in front just because it looks better. Okay, that is our solution. Now we're going to try another example, and this one we'll use method 2 on, and that is 3 over x minus 1 minus 2 over x, all divided by 1 over x minus 1 plus 3 over x. So we're going to use method 2 because you can see that there are similarities in the LCD. Actually, they're exactly the same. The LCD for the top and the LCD for the bottom are exactly the same. So this makes us want to use method 2, where we multiply the top and the bottom by x times x minus 1. Alright. This time I'm going to write all the steps out just to make sure that you get them all, but you don't always have to write them out. So when we distribute that x times x minus 1, then we get 3 times x minus 1 over x minus 1 minus 2x x minus 1 over x. So essentially what's happened is we've just stuck the LCD on every numerator. That's what you're doing. And then you can see what happens is that we'll use blue here, the x minus 1s cancel out there, and the x's cancel out there. So you got rid of the denominator. On the bottom, we're going to do the same thing, distribute. So we get, let's see, 1 times x minus 1 over x minus 1 plus 3x x minus 1 over x. And here the x minus 1's cancel, and over here the x's cancel, and we don't have any more of those denominators left. What we do have left is 3x minus, and then we'll distribute that too, so 2x minus 2 over x plus 3x minus 3. See, I put the parentheses over here, and then I didn't put them, whoops, I didn't mean to erase that. 3x minus 3. I don't have any parentheses down here. And the reason is because of this minus sign. We're going to have to distribute that. So if I don't put those parentheses, then I'm not going to get the +2 here that I really need. So be very careful. That's where most of the mistakes are made. Now, if I go through here, 3x minus 2x is x, and then minus the -2 gives us +2, over 3x plus, or sorry, x plus 3x is 4x minus 3. And we can't factor that, so there's nothing that cancels out, so we are finished. The last example that I'm going to show you for section 6.5 is one involving negative exponents. So here we have n to the -2 plus m to the -2 over 1 plus n times m to the -2. Now this, as it sits right now, it doesn't look like a complex fraction, but the negative exponents, if we remember how to make those positive, this is really saying n to the -2 is 1 over n squared. M to the -2 is 1 over m squared plus, or 1 plus, and then this is 1 over n squared m squared. So we really do have a complex fraction. And here we're going to use that second method of multiplying the top and bottom by the overall LCD, which is n squared m squared now that we have our common denominator, we want to distribute, right? We should put parentheses around here. So then we're going to distribute this guy to the top and to the bottom. I don't know why my pen's not working very well. Okay, so when we do 1 over n squared times n squared m squared, the n squareds are going to cancel out, and we just have m squared. Plus, here the m squareds will cancel out, and we have n squared over 1 times n squared m squared, plus here everything's going to cancel out, and we just have 1. And that's it. So something that started out looking kind of ugly and complicated, turns out isn't so bad. Alright, so that is it for lesson 6.5. Good luck!